OpenPuff. I'd like you to imagine that we have two users. We have Bob at a computer over here on the left, and we have Lois at a computer over here on the right, and they are connected to a series of networks that give them connectivity eventually to each other. Now, if Bob had a file, let's say that file was called secret.txt, and that secret file had confidential information in it that Bob didn't want to let anybody else know about except for Lois, how could Bob get that information over to Lois? We could use a virtual private network like IPsec or SSL or TLS and use encryption to maintain data confidentiality. So if Bob, using a virtual private network, uses the key called key, we'll call it 123, and Lois has the key called key 123, Bob could encrypt the secret.txt file, send it over to Lois, who could decrypt it, and then anybody in the middle who was trying to eavesdrop or access that information, because they wouldn't have the key, even if they got their hands on the file, they wouldn't be able to decrypt it without the key or understand the contents of that file. We'd also have a benefit with a virtual private network of data integrity, just making sure that that file and that content hasn't been manipulated somewhere in this cloud in the network as it made its way from Bob over to Lois. Now, what if Bob and Lois wanted to exchange that file, secret.txt, but they didn't have a VPN? How else could they do it? One of the crypto technologies that they could use is called steganography. And it's the process of hiding a file within another file. With steganography, Bob could take his favorite music file, we'll call it music.mp3, which he could open up with a player and listen to. Everything's great. The file's perfect. And what he could do is he could take the secret file, the secret.txt file, and encrypt it and encode it as part of the music.mp3. Now, as he does that encryption, there will be keys involved. Let's say that Bob used key 123 to do that. Now this music.mp3 file, if it was, for example, 1 megabyte in size, it's now going to be a little bigger. It's got the encrypted secret.txt in it. So now Bob can actually send that music.mp3 file via email or some other method over to Lois. And now Lois, when she gets the music.mp3 file, if she uses the same algorithms and she has the same key that Bob used to encrypt that data, she can take that music.mp3 file and decrypt out of that the secret.txt file. And the beautiful thing is, anybody on the network here, if they captured that file or they stole the music.mp3 file, there's two likely results. One, they won't realize that there's an embedded encrypted file as part of the carrier, in this example, the music file. And secondly, even if they did, if they don't have the keys involved, they still would not be able to decrypt that information. OpenPuff is a freeware steganography tool. It's been around for a long time, and it is very simple to use. It has a nice GUI interface. It runs on Windows. And what it does, it allows us to hide one file inside another file. And behind the scenes, it's actually using multiple forms of cryptography to make it very, very difficult for anyone who doesn't have the appropriate keys to unlock that file or that hidden content inside of the carrier. The process for using OpenPuff is very straightforward. You first of all do a Google search and download OpenPuff and run it. And then you're going to select, if you're going to do the encryption of one data file inside of another, you'd identify the password or passwords that you want to use as part of that encryption. That password that we're going to use is effectively part of the secret key that we're going to use for the encryption. We need to remember those password or passwords for the decryption on the other side. We also want to identify the file to be hidden or encrypted inside of the carrier. We'd identify the carrier. So in the example with Bob, the file that he was hiding is secret.txt, and the carrier file was a MP3 file. However, the carrier doesn't have to be just a music file. It could be an image, it could be an audio file, it could be a video file, it could be an Adobe document. There's lots of options as far as what the carrier could be. And the cool thing is, these carriers, once they have that encoded information, they're still valid files. You can still use them. So the recipient, if they want to play that MP3 file, it still plays like a normal MP3 file. And there's also some options regarding the encoding of that data. And then once our file is encrypted, in this example, the MP3 file, we can just send that any method we want to the recipient, who, if that recipient understands the keys that we used, which involves the passwords that we used to encrypt it, and the carrier files. Now the carrier files, I put that in plural because we could actually have more than a single carrier file. For example, if we have a huge file that we're trying to encrypt, we may have to use 1, 2, 3, 4 different carrier files. And let's say we did them in this order. The recipient would take those 4 carrier files, list them in that same order, specify the passwords that we used for the encryption, along with the bit options to go ahead and extract the hidden content. And I think what would be a lot of fun is let's do a simple demonstration of this right now. Now as a test, let's do this. I have OpenPuff open right here, and I've got a folder for OpenPuff, and I have source files. I've got two MP3 files, and I've got a little text file that we're going to treat as our secret document. And for a moment, let's just verify that we can listen to one of those. Let's pick Coast to Coast, and I'll simply play it. And let's use this MP3 as the carrier, and we'll go ahead and embed this little secret document as an encrypted file with steganography inside of the music file. And just for fun, let's go ahead and open up the secret document. And there's this secret document contents. Also down here, I've got this results folder, and I have a separate window of that results folder right here. So the first thing we're going to do is going to go ahead and click on the hide button inside of OpenPuff. What it wants here is it wants 3 passwords. Now, if we want to simplify this, we can say, you know what, forget B and forget C just for demonstration purposes. I just want to use a single password. So we put the password in. Now that password that I just entered is part of the key that is going to be used to encrypt our secret file into the carrier. So that's step 1. Our next step is step 2, identifying the file that we want to encrypt and hide. So I'm going to go ahead and use the browse. So we're going to select this secret document, and right here it's showing us details regarding that file, that it is 55 bytes in length. One of the things we'd want to be aware of if we're trying to encrypt a huge file, we might need a huge carrier or multiple carriers to hide that data into. For example, if our carrier was 20 bytes, the carrier would not be big enough to pull that off. So our next step, step number 3, is to go ahead and identify the carrier that we want to use. So we'll click on the Add button. And I think the one we agreed to is Coast to Coast, so let's go ahead and use Coast to Coast and click on Open. And if we wanted to add a second carrier, we could simply click on Add, and we'll grab this blues song as well. Now the reality is that our little text file is so small, it doesn't even need this second file, because the first file as a carrier is big enough. Now under bit selection options, if we go over to MP3, now the most important aspect over here is to make sure that for the decoding, the person who's doing the decoding knows which value we used. So part of the secret for the encryption is going to be all the passwords that we used, the actual name or names of the files we used as a carrier, and they need to be in the correct order, and also the bit options that are set over here. So in this case, we're not using blues country at all, so that won't be an equation for the decode. And then once we're done, we simply click on Hide Data. It's asking us, where do you want to put this? I'm going to say go ahead and put it in the results folder. Click OK. And this little warning message is simply saying, hey, that second carrier file isn't used, so when you do the decode, you don't need to mention blues country as part of it. And there's our new MP3 file. So I'm going to click on OK. There's a little summary of what happened. I'll click on Done. Now if we wanted to play this MP3 file, we could do that. And it plays just like it did before. Except if we looked at the details of this file in the results folder and the Coast to Coast file in the source folder, this one's going to be slightly bigger because it has the secret document text file encoded into it. So now the next piece is, how do we extract that out of it? Let's say we're on the receiving side and we want to extract our secret document out of this MP3 file. We simply go to OpenPuff, click on Unhide, and put in our password. And I'm going to remove the passwords for B and C because I didn't use those options to encrypt it. So we need to have the same exact information or key that was used during the encryption for the proper decryption. So the second step is to identify the carrier. So I'm going to go ahead and click on Add Carriers. And I'm going to go to the results folder, and there's our Coast to Coast file. So I'll go ahead and select that. And under MP3, it's currently set at medium level, and that's how it was encrypted, so that should work as well. So all we need to do here is click on Unhide. And now it's asking us for the location of where it should put that decrypted secret document file that was encrypted in the carrier. I'm going to put it also in this results folder down here. We'll click on OK, and it says it's done. There's a little summary, and here's our secret document right here. And if we open it up, we now have a copy of that document. Using steganography to hide one file inside of another is a fantastic and amazing use of cryptography.